So, what is Ohm's law? Well, Ohm's law states that the electrical current flowing in a circuit is proportional to the voltage and inversely proportional to the resistance. And that may be confusing. So we can do a visual demonstration to put those words into a visual picture. And we'll do that now. So what I'm going to do is we're going to power an LED from a DC power source. So on the top of the screen here I've got my DC power source, and I'm going to drag that onto the screen. And now that's set at 1 volt. If I highlight it yellow, at the bottom of the screen I actually get an adjustment option at the bottom, so I can adjust the properties of any component on the screen. If I click that, I'm going to set that to 5 volts. Because we're going to pretend we're running this off a 5 volt USB power supply. We're going to get this 5 volt power supply, and we're also going to find an LED. So an LED looks like a diode with arrows coming out of it. And just to demonstrate, if we connect this LED directly to this power source, so positive to positive and negative to negative, and we need to connect the ground symbol in every circuit. It likes to give you practice in using the ground symbol in circuit schematics. So the ground symbol just indicates where the negative connection is. And if I click play at the bottom, we'll see a visual demonstration of this circuit. Okay, so I've pressed play and we've just blown our LED up. And the reason we've blown our LED up is if we click on the LED and view its properties, we can see that this LED's voltage drop is 3 volts. That's the voltage that the LED requires to light up. And the current it draws at 3 volts is 20 milliamps. So we're actually supplying 5 volts to a 3 volt LED. And that's bad because it's drawing way too much current and it's just blown up. It's way too much for the LED to handle. So what we need to do then is we need to introduce a resistor to this circuit. And if we cut the circuit and we grab a resistor from the top, and if we drag this over and connect this up to our circuit, we'll put the resistor in series in our circuit. So it's in series with our LED. This resistor is set to 1 kilo ohm. And if we press play on the circuit, and we can see the current flowing through the circuit, we've only got 2.34 milliamps. And if you remember, if we look at the LED's properties, it actually requires 20 milliamps to light up, and 3 volts. And it's only getting 2.66 volts and 2.34 milliamps. So what we need to do is calculate the resistance that we need to introduce to the circuit in order to meet the conditions that this LED lights up at 3 volts and 20 milliamps. So this is where we start to use Ohm's law. And we can see Ohm's law on this screen here, where we've got our Ohm's law triangle. So we've got V, I and R. That V is voltage, I is current, and R is resistance. So the unit for voltage is volts, the unit for current is amps, and the unit for resistance is ohms. So we need to calculate the correct resistance for the circuit in order to light this LED. We've got an LED that requires 3 volts, but we're supplying 5 volts. So in order to limit the current to our LED, we need to keep 3 volts for our LED. So if we take away 3 volts from the 5 volt power source, we're left with 2 volts. And so this is where we will use Ohm's law, as we need to introduce a resistor to drop that additional 2 volts and limit the current for the LED. So now with that 2 volts we can calculate the resistor value we need in order to drop those 2 volts and supply the LED with 20 milliamps. If we go and have a look at our Ohm's law triangle, then we know 2 values now. We know current and we know the voltage. The voltage is 2 volts and the current is 20 milliamps. So we're looking at this equation here. Resistance is equal to 2 volts over 0.02 amps. So we always write the current in amps in our equation. So if we do that calculation using a calculator and we go ahead and do 2 volts divided by 0.02 amps, our answer is 100 ohms. So 2 volts divided by 0.02 amps or 20 milliamps equals 100 ohms. So we know now that we need to adjust this resistor in our circuit to 100 ohms. So we can see now that we've got our resistor set to 100 ohms, and I've put a voltmeter across the resistor here to show that this resistor is taking the 2 volts away from the circuit and limiting the current to 20 milliamps. So now, because this resistor has taken away 2 volts from our 5 volt power source, we're left with 3 volts in our circuit, which is powering the LED, and the resistor is limiting the current to 20 milliamps. So our LED is now being provided with 3 volts at 20 milliamps. And that's the current that we actually required to light our LED as specified in the LED's properties, 3 volts and 20 milliamps. Now we can go ahead and do a visual demonstration of what Ohm's law states. So it states that electrical current in a circuit is proportional to the voltage and inversely proportional to the resistance. So while keeping the resistance in the circuit the same, I'm going to adjust the voltage. So we're going to increase this 5 volt supply to 6 volts. So I've added 1 volt, and we can see here that the current has increased. So as I have increased the voltage, the current has also increased. And if I decrease the voltage in the circuit to 4 volts, we can see the current in the circuit has also decreased. So we're now down to 10.9 milliamps, and that LED is barely lit. I'm going to set this back to 5 volts, and now we're going to adjust the resistor value while keeping the voltage constant, or keeping the voltage the same. So Ohm's law states that current is inversely proportional to the resistance. And to show what that means, if I increase the resistance to 200 ohms, so that's the inverse part of the equation. You increase the resistance, and therefore the current decreases. And if we decrease the resistance, so we'll take that to 50 ohms, if we decrease the resistance, the current increases. And technically we're providing way too much current to that LED. If we take that resistance down a little bit more, it might blow up. There we go, it's gone. Too much current is flowing through that LED. So we've decreased the resistance enough that too much current is flowing through to the LED.